In this video I'll be presenting my project for the PN4035 module. I'll be presenting the function of all mechanisms and individual parts, including an outline on material selection and component selection. In this video I'll also be outlining the manufacturing processes and the impact on operating conditions. So in this part of the video I'll be going through the electricity generation of the wind turbine. So the electricity generated will come from the kinetic energy of the turbine's blades converted into rotary energy. This rotary energy will turn the repurposed RS365 SA DC motor, converting the kinetic energy into electrical force. This electrical force will travel through a diode, which will be situated at the back of the DC motor, prevent back EMF and deliver the current to the rechargeable battery. A microcontroller, which will control the system to monitor the RPM of the DC motor and ensure that the correct outputs are met, hitting charging specifications for their repurposed USB component. Part of the video I'll be going through some of the parts and developing on their design. So this is the base piece, and the purpose of the base piece is to hold down our turbine. So we see we have a few extruded threads here and here. So this would be for housing the lower mast, and this would be if the individual user wants to mount their turbine down to something. So here we have the right part. We see our extruded cut. That is for the USB component housing, which would be repurposed. So I've decided to make this out of aluminium, as bauxite is a natural resource scattered all across Ghana, and it would be manufactured on the milling machine. Here we have the working drawings of our base part. So here we have our lower mast piece. It will be made from aluminium and it will be manufactured on the CNC lathe. See, we have our threads cut to connect into our base piece. We have more threads cut up here to connect into our upper mast, and our extruded cut for our USB output. So here we can see our assembly of our base piece and our lower mast piece connected through the threads. Our upper mast, which will be made from the same material and manufactured in the same process as our lower mast. As we see the threads will connect into our upper housing, and we also see our threads at the bottom which connect into the lower mast. So here we have the assembly of our upper mast and lower mast. It is designed similar to a boat mast, so it will be wider at the bottom for additional strength, and if you look from a top view we can see that this is where the wires will be fed down into our USB component. And here we have the working drawings of our upper mast and lower mast. We have our turbine's nose, which will convert the kinetic energy of the blades into rotary energy. As you can see, we have our threads cut out for our blades, our axle and our spur gear, which will act on the DC motor, converting the rotary energy into electrical energy. This is produced through companies such as Qualiplast, who use recycled plastics in extrusion molding processes. We have our turbine's blades that will harness the kinetic energy. Using the threads, it will be connected into the nose piece, which will convert kinetic into rotary motion. So this will be manufactured also by companies such as Qualiplast using extrusion molding processes. Here is the assembly of the turbine's blades and the turbine's nose. The drawings shown are the working drawings for the turbine's nose and blade. The wind turbine, which will contain all the essential components for the electricity generation, it will be manufactured using a blow molding process with recycled plastics. To create the left housing, we will use our exact same processes and measurements, and we will mirror it on our right plane. Here is the assembly of our turbine's left and right housing. And finally we have the working drawings of our turbine's left and right housing. Analysis of the operating environment and the climate of Ghana, I do think that the wind turbine is the best suitable design. There's many considerations such as the density of materials at the bottom of the mast, and even the blades, which are prone to snap, can be detached and attached onto the turbine's nose. Any components used in this design have been imported and will be referenced at the end of the video. Thank you for watching.